we're going to look at fuels, and we're specifically going to look at the experiments based on the production and properties of ethene and ethine. So our learning intention is to examine the properties of ethene and ethine through their preparation. So the first experiment that we're going to go through is we're going to look at the production of ethene. And production of ethene has the following setup as in the diagram. So as you can see, you've got a Bunsen burner and it's heating aluminium oxide, which is a white powder. And this test tube here is clamped to a retort stand. It's just not shown in the diagram. So the Bunsen burner is kind of moved along underneath the aluminium oxide. And what happens is that causes the test tube to heat up, and the ethanol starts to evaporate from the glass wall, and it starts to float over the aluminium oxide. And when it's doing that, it's getting dehydrated. So the ethanol is losing water and forming ethene gas, which flows through this tube and into our test tube here. This test tube is completely filled with water, and the ethene collects here by a process called the downward displacement of water. So you would complete this process in order to collect a few test tubes of the ethene gas to test them for their properties. And this is an example of an elimination reaction and can often be referred to as a dehydration. So the first thing to do would be to, when you collect the ethene, to have a look at its physical properties. So first of all, it's a colourless gas. It has a sweet smell. We know that it's insoluble in water, and you know that because on the previous slide you can see that the ethene is collected through the downward displacement of water, so it doesn't dissolve in the water itself, it pushes the water out of the test tube. But it is soluble in organic solvents such as cyclohexane. If we were to do a combustion test on ethene, a lit taper would be placed in the test tube of ethene gas, and you would get a bright luminous flame. And you would know this combustion that will have occurred because combustion involves the production of carbon dioxide and water. So to test that it's occurred, you could use lime water, which turns milky, and that shows the presence of the carbon dioxide. The next test you would do to test the properties of ethene is the bromine water test. And bromine water will be added to the test tube of ethene. It will be stoppered and shaken, and you would see that the bromine water changes from red to colourless. This is often maybe an orange to colourless depending on the concentration of the bromine water. And this colour change shows the presence of the double bond that's in ethene. Similarly, for the acidified potassium permanganate test, you add a few drops of acidified potassium permanganate to your test tube of ethene, you stopper it and shake it, and you will see that you'll get a colour change from purple to colourless. And this colour change again shows the double bond present in ethene. So let's look at some questions that could potentially come up in an exam. The first one is to describe the appearance of the aluminium oxide and its purpose. So first of all, aluminium oxide is a white powder. It acts as a catalyst and a dehydrating agent. And we know that it acts as a dehydrating agent because this is a dehydration reaction. The next question is, why is the glass wool not heated directly? So we don't place the Bunsen burner under the glass wool, and the reason for that is because the ethanol that the glass wool is soaked in is flammable, so it could cause an explosion. Next, why must the delivery tube be removed from the water before the heat is removed from the test tube itself? And that is to prevent a process called suckback. And suckback is where water travels up through the delivery tube into your glassware, causing the glassware to shatter, and that will be due to the hot temperature and the cold water coming in contact. The next question is, why is the first test tube of the gas collected discarded? And that's because it mainly contains displaced air. So the displaced air would come from air that was inside the equipment that needs to be pushed out before the sample of ethene gas could be collected. Why is it necessary to use acidified potassium permanganate to test for unsaturation? And this is because without the H+ ions from coming from the acidification, the potassium permanganate would not be able to act as an oxidizing agent, so it would be deemed useless. The last question then that's commonly asked is to give a use of ethene, and a use of ethene is in ripening of fruit. So that's the ethene experiment completed. Next, let's look at the production of ethine, and as you can see, the setup here is quite different to that of the production of the ethene. So for ethine, your main chemicals that you're using are calcium carbide here and water, which is in a dropping funnel. And you open the dropping funnel, allowing the water to drip down into the calcium carbide. It causes it to fizz, and the ethine gas is produced and passes through this tube along here into our acidified copper sulfate. Now, it passes through the acidified copper sulfate in order to remove impurities such as nitrates and phosphates. And once the ethine has been purified, it travels through this tube and is collected into your test tube. And again, it's collected by the downward displacement of water. So this would show again that ethine gas is also insoluble in water, because when the ethine gas comes into the test tube, instead of just dissolving in the water, it actually pushes it out. So let's take a look at some tests for the properties. And if we look at the physical properties to start with, again, ethine is colourless. It also has a sweet smell, it's insoluble in water, and it's soluble in organic solvents. So that's the exact same as ethine. The combustion test is slightly different. A lighted taper is placed into a test tube of ethine gas, and a sooty flame is produced. So a lot of soot should be produced. There will be a pop, and it will produce lots of soot. And this soot is formed from unburned carbon in the combustion reaction. Another test you could do is the bromine test, where again bromine water is added to the test tube, it's stoppered and shaken. The bromine water will change from red to colourless, and it could be orange to colourless depending on the concentration of the bromine water, and this shows the presence here of a triple bond in ethine. Similarly, for the acidified potassium permanganate, a few drops of it are added to the test tube, it's stoppered and shaken, and the colour change that occurs is purple to colourless, which again shows the presence of the triple bond present in ethine. So the last thing to do here would be to look at possible experiment questions that would come up in an exam. And sample 1 is describe the appearance of the calcium carbide. It is a solid grey-brown material. The next question, why is the water added to the calcium carbide dropwise? So basically, why don't we just fire a load of the water in? And that is to control the rate of production of ethine. We want a steady rate of production so that we can collect a number of test tubes. Why is it necessary to bubble the ethine through acidified copper sulfate? And that is to remove impurities, as I said earlier in the video, and these impurities would be nitrates and phosphates. The next question is, why is the first test tube or gas jar discarded? And again, that's similar to the ethene experiment. It's because it contains mainly displaced air. And what substance is left in the Buchner at the end of the experiment? So you will see a white powder on the walls or at the bottom of the Buchner flask after the experiment has been completed. And that is sodium hydroxide that is present there. The last one then is to give a use of ethine, and a use of ethine is for oxyacetylene welding. And that's the ethine experiment complete. So that's it for this video. Have a read over the learning intentions to make sure you understand everything we've gone through.